Good day, everyone. I'm Bin Kang. Today I'm going to talk about an article titled Azimuthally Symmetric Theory of Gravitation 1 on the Perihelion Precession of Planetary Orbits. This article is by Gigi Nyambuya from Northwest University in South Africa. This paper takes the azimuthally symmetric equations of the well-known Poisson equations and apply them to gravitation. For zeroth order approximations, this equation is reduced to in agreement with Newton's gravitational law. An example of azimuthally symmetric setting is a spinning gravitational system like the Sun. The failed attempt of Newton's theory of gravitation to explain the precession of planet Mercury perihelion of 43.1 arc-second per century, that is, the orbit of Mercury is shifted by 43.1 arc-second per 100 years at the perihelion. This was solved by Einstein's general theory of relativity to a very precise value of 43 arc-second per century. This theory explains the phenomenon as a result of curvature of space-time around the Sun that makes the Mercury orbit shifted, but Einstein's general relativity doesn't consider the fact that the Sun spins, and it assumes all planets they are all lie on the same plane, while in reality they are not. Azimuthally symmetric theory of gravitation explains the precession of planet Mercury by taking into account the solar spin. From this table, we can see the comparison between the observation value, Einstein's general relativity value, and azimuthally symmetric theory of gravitation value of the precession of planet orbit in the solar system. Values are compatible by observation results except for Uranus, Neptune, and Pluto, where there's no consistent or reliable observational result. The difference between this theory compared to the Einstein general theory of relativity as well as Newton's gravitational law is that the orbital angular momentum is not conserved in this theory. The lost angular momentum is transferred to the spin of the orbiting body as well as the Sun. Through this fact, the theory explains two observational phenomena that are the circular increase in the Earth-Sun distance, that the mean distance between the Earth and the Sun is slowly increasing by 7 to 15 meters per 100 years. The second is the circular increase in the orbital period of planets, that the Earth day increases by 1.7 milliseconds per 100 years. The problem with this theory is that there are constants like lambda sub L and gamma they can only get from the observational result for now. They are still trying to get the nature of these constants, but for now, the only way to get is through observational results. In conclusion, this paper takes the azimuthally symmetric equations of the well-known Poisson equation and apply them to gravitation. Works still need to be done to make the lambda sub L and gamma constants numerically quantifiable instead of just depending on the observational results. Otherwise, this theory explains successfully the precession of planets orbital perihelion in solar system using the Sun spin and two observations with the concept that the orbital angular momentum is not conserved. Thank you. That's the end of this video. Have a nice day.